Hello everyone, my name is Nick Ocott, and this is my Physics Lab 1. So for the introduction, the purpose of the lab was to observe the charged pieces of clear tape and to determine how much excess charge is on one piece of tape. The models and fundamental principles were Newton's second law, which is F equals ma, the third law, which is every action has an equal and opposite reaction, and Coulomb's law, which is, of course, used. And the results are the tape is positively charged because it is attracted to a negatively charged pen. The magnitude of the gravitational force on the tape is 1.962 times 10 to the negative 3 newtons, and the charge on the tape was 9.34 times 10 to the negative 9 coulombs. And here are some of the formulas I used to help calculate my numbers. All of these are pretty standard, so I'll move on to the next slide. For the assumptions I ignored air resistance, and I also assumed that each U-tape, each upper tape, has the same net charge, and that also to treat each tape as if all of its charge were located at a single point at the center of the tape, like a point charge. And so for procedure 1, you had two pieces of tape taped together, and you would put them on an edge, and then you would perform experiments on them. So when you put a hand close to the tape, there's an attraction. But when you put two pieces of tape close together, there's a repulsion. And then when you put a tape plus a pen together, there's an attraction. And the pen was negatively charged because it was run through hair, and because of that, the pen became negatively charged. And because it's negatively charged and it was attracted to the tape, the tape was positively charged because opposites attract. So for a what-if statement, what if the electrons had a positive charge and protons would be negative? Well, this would not really affect the experiment, as it wouldn't affect it at all, because the charges would still repel against each other, and this experiment would still work. So for the why statement, why is it important to handle the charged tapes as little as possible? Well, the more you handle the tape, the more charge from the tape goes onto your hand, and therefore it makes the experiment less accurate. It's to help keep the tape as positively charged as possible, and it's to help prevent human error in the experiment. For procedure 2, you had a piece of tape, tape A, and the piece of tape, tape B. And the tape B is the system, while tape A is the surrounding. And the goal was to make the electric force from tape A equal to the gravitational force on tape B. And then, so for the mass, here for the mass I got 0.0022 kilograms, the length I got 0.2 meters, the distance between the tape I got 0.02 meters, and the gravitational force and charge on the tape I also told you guys earlier. So here are my calculations I used for the previous slide. I did them by hand, and I also checked them through the coding software. On the left I have the constants, which I put in, the mass, the length of the tape, the distance, g, and then on the right are my actual calculations. For the charge, it's the square root of the mass times g, which is, of course, is the force of gravity, times the distance squared, divided by 9e9. And through all of these, through using all the formulas, that's how I found all the numbers. And so some sources of error could be the tape was touched for too long / too much. The charges on the tape could have moved from the tape to my hand. And also the wind could have played an effect on the tape. The wind can push the tape upwards, which can add some error in the system. And here's my code that I used to help calculate the numbers and to help check myself. That is it. Thank you, and have a nice day.